friends, welcome to Aparna's Think Maths. In this session, we are going to discuss about extra questions on Chapter 1. So already I have posted videos on all the book bag exercise from Chapter 1. So if you need, you can check the links. Okay. Now the first question is, what is the HCF of smallest composite number and the smallest prime number? So first, what is a composite number? So a composite number is a number that is divisible by 1 itself and many other numbers. So that numbers are called composite number and prime number. So prime number is nothing but divisible by 1 and itself. Okay. So those numbers are called prime numbers. Okay. So now we have to find the HCF of the smallest composite number and the smallest prime number. So what is the smallest composite number? So let us start with 1. So 1 is neither prime nor composite. 2 is a prime number because it is divisible by 1 and 2. Next 3 is also divisible by 1 and 3, that is 1 and itself. Next number is 4. So 4 is divisible by 1 itself and 2. So 4 is the smallest composite number. Okay. So next one, smallest prime number. So smallest prime number is 1 is neither prime nor composite. So smallest prime number is 2. Okay. So this 4 can be factorized as 2 into 2. That is 2 to the power 2. This is 2 to the power 1. So now we have to find the HCF of 4, 2. So HCF is nothing but product of the smallest power of the common prime factor. Okay. Here the only prime factor is 2. So it is smallest power is 1. So the HCF of 4, 2 is 2. Okay. So next question. The decimal expansion of 6 divided by 1250 will terminate after how many places of decimal? So without performing the long division, we have to find whether this expansion terminates or not. Okay. So 6 divided by 1250. So 6 can be easily factorized as 2 into 3. Now we have to factorize 1250. So as it ends with 0, we can take 2 or 5. So let me take 5. 5 2s are 10. Balance will be 2. 5 5s are 25. 0. Again I am going to take 5. 5 5s are 25. 0. So again let me take 5. 1 5s are 5. 0. Again 5 is taken. 5 2s are 10. So 2, 1. So how many 5s are there? 4 5s are there. So it can be written as 5 power 4 into 2. Okay. So this new denominator is of the form 2 power n into 5 power n. So we can easily say that this expansion will terminate. So now we have to find how many decimal places are there. So instead of just multiplying, I am going to equalize the powers. Here the power is 4. For the number 2, the power is 1. So to equalize the power of 2, I have to multiply by 2 to the power 3. Okay. So 2 into 3 divided by 5 to the power 4 into 2 to the power 1 into 2 to the power 3. So again here also in the numerator also you have to multiply by 2 to the power 3. So here, so what is the value in the numerator? So 2 to the power 4. That is 2 to the power 4 means 2 2s are 4. 4 4s are 16. 16 into 3. So if I multiply all the 2s, it is 16 into 3 divided by, this can be written as 5 into 2 to the power 4. So both 5 and 2 has the power 4. So I can write as 5 into 2 to the power 4. So let me erase this factorization. So which is equal to 16 into 3. So 6 3s are 18, balance 1, 1 into 3, 3 plus 1, 4. So 48 divided by 10 to the power 4. So there will be 4 zeros. So you have to place the decimal before 4 points. So already there are 2 numbers. So we have to add 2 zeros. So 0.0048. So the decimal places will be before 4 places. Okay. So the answer is the decimal expansion of 6 divided by 1250 will terminate after 4 places of decimal. Okay. So next question. So if HCF of A and B is 12 and the product of these numbers is 1800, find LCM. So we already know that product of two numbers equal to product of their LCM and HCF. So they gave the answer for HCF. So HCF of two numbers is 12 and their product is 1800. We have to find the LCM. So product of two numbers is 1800. So product of LCM and HCF. So HCF value is 12. So 12 into LCM. So then LCM will be equal to, this 12 will come down if we take it to other side. So 1800 divided by 12. So if I divide by 12, 1 12s are 12, balance will be 6. So 5 12s are 60. So here 1 0 will be there. So answer is 150. Okay. So next question. Find HCF of 3 power 3 into 5 and 3 power 2 into 5 power 2. So we know that HCF is nothing but product of the smallest power of the common prime numbers. So the here common prime numbers are 3 and 5. So their smallest power. Power of 3 is, that is smallest power is 2. For 5, smallest power is 1. So 9 into 5. So 3 square is 9. 9 into 5 is 45. Okay, can you understand? So let me go to the next problem. Question number 5. If A is an odd number, B is not divisible by 3 and LCM of A and B is P. What is the LCM of 3A and 2B? So they gave LCM of A and B is P. So we have to find the LCM of 3A and 2B. So if the LCM of A and B is P, then LCM of 3A and 2B will be, LCM of 3 and 2 is 6. So it will be 6P. Okay. So 6P. So let me check this with an example. Suppose let me take A is equal to, so they gave A is an odd number. So let me take A is equal to 3. B is equal to, so B is not divisible by 3. So I take 4. So 4 is not divisible by 3. So their LCM is, so this 4 can be written as 2 to the power 2. So LCM is nothing but product of the greatest power of all the prime numbers. So the prime numbers are 2 and 3. So power of 2 is, greatest power is 2, greatest power of 3 is 1. So it is 12. 4 into 3, 12. Okay. Now 3A and 2B. 3A and 2B. So 3A. So 3 into A is 3 3s are 9 and 2B. 2B means it is 6. No, 8. 2 into 4, 8. So this can be written as 3 square. So this can be written as 2 to the power 3. So their LCM is, so the only prime factors are 2 and 3. So their greatest power is 2 to the power 3, 3 to the power 2. So it can be written as 2 to the power 3 is 8. 3 to the power 2 is 9. So 8 into 9 is 72. So 72 can be written as 6 into 12. So 12 is nothing but, so they gave LCM of A and B is P. So this 12 is nothing but P. So it is 6. Okay. So I verified it using numbers. So LCM of 3A and 2B will be 6P. So already they gave the LCM of A and B, which is P. So 3A and 2B will be 6P automatically. Okay. So next question. If P is a prime number, then find LCM of P, P square, P cube. So they gave P as a prime number. Suppose I take 5. So this prime number cannot be factorized any more than 1 into 5. Okay. So P square will be 1 into 5 whole square. That is 1 square into 5 square. P cube will be, so P square is nothing but 1 square into 5 square. In the same way, P cube. So P square is nothing but 25 square. Okay. No, 25. P square equal to 25. That is 5 into 5. 5 into 5 is nothing but 1 square into 5 square. So P cube is nothing but 5 cube. So their factorization will be 1 cube into 5 cube. So the LCM of P square, P cube will be, so what will be the LCM? LCM is nothing but product of the greatest power of all the prime factors. So here the prime factor, only prime factor is 5, that is P. Okay. So P is the only prime factor. So it is greatest power is 3. So P Q. So LCM equal to P Q. Okay. So next problem. Two positive integers P and Q can be expressed as P is equal to AB square and Q is equal to A square B. A and B are prime numbers. We have to find the LCM of P and Q. So here A and B are prime numbers. They gave the value of P as AB square and Q as A square B. So since they are prime numbers, you cannot factorize further. So their LCM will be automatically A square B square. So automatically LCM of P comma Q will be A square B square because A and B are prime numbers. So we cannot factorize further. So LCM is nothing but product of the greatest power of all the prime numbers. So the prime numbers are A and B. Their greatest power is 2 and for the greatest power of B is 2. So the LCM of P comma Q is A square B square. Okay children, can you understand? So let me go to the next problem. So a number n when divided by 14 gives the remainder 5. What is the remainder when the same number is divided by 7? So let me take a number 33. So this 33 gives the remainder 5 when you divide by 14. So when you divide by 14, so 2 into 14 is 28. So the remainder is 5. So the question is, what is the remainder when the same number is divided by 7? So I divide 33 by 7. So this goes 4 times. Okay. 7 4s are 28. So what is the remainder? I get the same number because 14 is a multiple of 7. So if the number is same, that is if the divisor is 14 and 7, because both their divisors are same, that is 7. So their remainder will also be same. Okay. So 14 is a multiple of 7, then remainder will be same in both the cases. So this number is same. 33 is same in both the cases. So the remainder will also be same. Okay. So next question. So check whether 17 by 30 is terminating decimal or not. So we have to factorize the denominator. So 17 is a prime number, so we cannot factorize. So 30. So 30 is factorized as, let me take 2. 1 2s are 2, 5 2s are 10. Again 3 can be taken. 3 5s are 15. So 5, 1. So denominator can be written as 2 into 3 into 5. But this denominator is not of the form 2 power n into 5 power n. So because there is one extra 3. So we cannot say that 17 by 30 is terminating. So it is not terminating. Okay. So 17 by 30 is non-terminating decimal. Okay. So next question. What are the possible values of r when a positive integer is divided by 3? So this is by Euclid's division lemma. So here we have to take the value for b as 3. So according to Euclid's division lemma, a is equal to 3q plus r, where r takes the value greater than or equal to 0, less than b. So here b is equal to 3. Okay, some values for q and a, we can say Euclid's division lemma says that a is equal to 3q plus r. Okay, so here r takes the value, so then r will be automatically 0, 1, 2. Okay, so r takes the value 0, 1, 2. Next question. A rational number in its decimal form is 1.7351. What can you say about the prime factors of q when the number is expressed in the form p by q? So here the decimal expansion terminates. Okay. So then by theorem we can say that q must be of the form 2 power n into 5 power m, where m and n are integers. Okay. So as it is a terminating decimal expansion, we know by theorem q is of the form, that is denominator is of the form 2 power n into 5 power n. Okay. So next problem. Without actually performing the long division, find whether 987 divided by 10500 will have terminating or non-terminating repeating decimal expansion. Okay. So first let us factorize the numerator 987. So let me take the prime number 3. 3 3s are 9. So here 2 3s are 6. Balance will be 2. 9 3s are 27. So if I take 3, 1 3s are 3. This 29 is not divisible by 3. So we cannot take 5. Let me take the next prime number 7. So 7 4s are 28. Balance will be 4. So 7 7s are 49. So 47 is the prime number. So we can stop here. So next is 105. That is denominator 10500. So let me take 5. 5 2s are 10. 1 5s are 5. 2 1 0 0. So this 21 is divisible by 7. Okay. So 7 3s are 21 0 0. So again I take 5. So 5 6 are 30. 0. Again I take 5. 5 1s are 5. Balance 1. 2 5s are 12. So you can take 3. 3 4s are 12. 2 2s are 4. So numerator is factorized as 3 into 7 into 47. Okay. So denominator, let me start with 2. 2 is repeated 2 times. So 2 to the power 2. 3 is repeated 1 times. And 5. 5 is repeated 3 times. So 5 to the power 3 into 7 is repeated 1 time. Okay. So here this 3 and this 3 gets cancelled. Also 7 gets cancelled. So remaining will be 47 divided by 2 to the power 2 into 5 to the power 3. So here the denominator is of the form 2 power n into 5 power m. So we can say that this rational number has terminating decimal expansion. Okay. So can you understand? So as q is of the form 2 power n into 5 power m. Here n is equal to 2 and m is equal to 3. Then 987 divided by 10500 has terminating decimal expansion. So next problem. What is the least number that is divisible by all the numbers from 1 to 10? That is, we have to find the LCM of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So first we have to factorize all these numbers. Here I have factorized the numbers 1 to 10. Okay. So we have to write the product of the greatest power of all the prime numbers. So what are the prime numbers here? 1, 2, 3, 5, 7. So 1 into, 2 into, 3 into, 5 into 7. So the greatest power of 2 is 3. So 2 to the power 3 and greatest power of 3 is 2. So 3 to the power 2 and greatest power of 5 is 1. Greatest power of 7 is 1. Okay. So 2 to the power 3 is 8. So 8 into 3 square is 9 into 5 into 7. Okay. So 8 into 9 into 5 into 7. So can you calculate the answer? So the answer will be 2520. Okay. So I think you can easily calculate the answer by any one method. So I have already posted some shortcut methods which you can check the link. So let me go to the next problem. Find the sum of 0.68 bar plus 0.73 bar. So here this bar indicates that 68 is repeated and 73 is also repeated. So let me take x is equal to 0.68 bar. So this is nothing but 0.686868. This will be repeated without n. That is non-terminating repeating decimal. Okay. So I am going to multiply by 10 on both sides. So if you multiply by 10, your decimal point will be forward. That is 10 into x will be equal to 6.86. So one decimal will be forward. So 6.8686. So if I again multiply by 1000, that is if I multiply x by 1000, there are 3 zeros here. So 3 points will be forwarded. So it will be 686.86. Okay. So now I am going to subtract 3 minus 2. So if you subtract 1000 minus 10, it is 990. So if you subtract this right hand side, that is 686.86868 and 6.86868668. So here it will be, if you subtract this will be almost equal to 000 something. Okay. So it will be 680 point some zeros. So you can write as 680. Okay. So 990 x equal to 680. So then x will be 680 divided by 980. So zeros will be cancelled. So answer will be 68 divided by 99. So in the same way you can write 0.73 bar will be equal to 73 divided by 99. So 0.68 bar plus 0.73 bar will be equal to 68 divided by 99 plus 73 divided by 99. So 68 plus 73 is 141 divided by 99. So we have to find the values for this. So whether 3 is divisible for this. So let me check whether 141 is divided by 3. So how much? 4 3s are 12, balance will be 2. So 7 3s are 21. So this is 0. So 47 divided by, so 33. Okay. So we have to divide this 47 by 33 and check the answer. 47, 33. I think it goes 1 times. So 7 minus 3 is 4. 4 minus 3 is 1. So we cannot divide this 14. So I add 1 0 and a decimal point here. 140. So I think it goes 4 times. So 4 3s are 12. Balance 1. 4 3s are 12. 132. So 140 minus 132 is 8. So I add 1 0. I think this goes 6 times. No, it goes 2 times. 2 into 33 is 66. Again the balance is 14. So you have to add 1 0. Again from this step this will be repeated. That is 140 is the answer. So again we have to multiply it by 4. So that is 132 will come. This 4 2 will be repeated continuously. So the answer is 1.42 bar. That is 1.424242, etc. Okay. So that's all for this session. Thank you for watching. So if you like this video, just share, like and subscribe and hit the bell button without forgetting. Okay.